So guys, welcome back to my YouTube channel. Today we are going to see on the solution part of this problem, that is minimum stack. So it is a medium level problem. Problem number is 155. We have already seen the description part of this problem. In this video we are going to solve this problem. So in order to solve this problem, we are going to create two stacks. So first one, stack 1, and the second one is stack 2. Okay. So what is the use of this second stack? It will return as the minimum value in the first stack. Okay, it will always give us the minimum value present in the first stack. That's why we are using it. So let's see this particular example. That first we need to initialize the minimum stack. So we are going to use the normal way, that is that stack, then your data type, then name something. Okay, so we are going to name it as stack 1 is equal to new stack. Okay, like that. New stack. Okay, and similarly for the second one also we are going to do the same thing, and we will place this in the min stack min stack function, which is going to initialize the stack. Okay, now moving on to the second part, that is push. So we are going to push -2. So what we are going to use simply the push function, that will add -2 to this stack. Okay. One more thing, we are going to add -2 to stack 2 also, because it is going to return the minimum value. So uh, we are going to write one thing, that if S2 is empty, basically it does not have any element right now. So we are going, or one more condition we are going to write, we are going to check it later. So if S2 is empty, then we are going to push to S2 also, because it is going to give us the minimum value, and right now suppose it does not have any element, and we are going to push our first element. So this will tell that, okay, the first element is the minimum element itself. Okay, and one more thing is that since this is the minimum value stack, so the value at the top of this, top of this stack will tell us the minimum value of the stack. So if we are getting a value basically less than the top of this stack 2, so that will become our minimum value. So we are going to write one more condition, that if what stack 2 dot peep, some peak function is there now. So if that value is greater than our current value, what we are going to do is we are going to add it to stack 2 also. We are going to add it to stack 2. So yeah, this is going to be the push function. Okay, suppose we are going to take one example. Suppose that we encountered -3 again. So we are going to add -3 and check that whether this, the minimum value in the stack, that is -2 right now, is it smaller than or greater than our current value, that is -3. So we will get that it is greater than our current value. So if stack 2 dot peak is greater than the current, we are going to push -3 to this particular thing. Okay, so now this will give us the minimum value in the stack right now. So that's the thing. Now pop, for pop function, we are just going to pop this thing out. Okay, and one more thing we need to do. Suppose the element that we are popping is the smallest element. So we need to pop this thing also, so that in future if we use peak function, it will not return this function minus this element -3, because we have already popped it out. So suppose what I'm trying to say is uh, yeah, so suppose -3 is there, okay, right now, and we have used the pop function. So it will remove this thing -3 from stack 1. And if we will not remove -3 from stack 2, what will happen? Suppose if we are using the get minimum function to get the minimum value from this of the stack. So what we are going to do, we are going to check the peak function, peak of stack 2. Okay, so it will return -3 only. That is all, that is not present in our the initial stack. So it will give us wrong solution. So in order to avoid that, what we are going to do, we are going to check that if the element that we are pushing is also present at the top of this stack 2, we are going to pop this thing also. Okay, so that was the logic for the pop. Now for top, nothing, just we need to use the peak function. It will return the top of basically the stack 1. Peak dot stack 1 what we are going to use. And in order to get the minimum function, we are going to use the peak function for stack 2. It will return as the minimum value. So I hope it is clear. Okay, so we will quickly code this particular problem.